So now we can see experiment number 6, contingency analysis. So contingency analysis, this is a program for contingency analysis. So we need to find the contingency analysis with the help of linear sensitivity factors. So there are two linear sensitivity factors, number one generation shift factor and number two line outage distribution factor. So generation shift factor, the formulas and everything it is there. ALI is delta FL divided by delta PI. So that was here programmed. So we have taken, I have taken a sample 3-bus system. So the reactance between 1 and 2 and the reactance between buses 2 and 3, reactance between buses 1 and 3 have taken as an input, and then you calculate the impedance of that is LIMP in that variable, line number 6 is given. Then the generated power demand and the base value has been taken as the input. Then you can find the susceptance value V0. You can run a DC load flow. We need to run the DC load flow, and then we can find the generation shift factor and then line outage distribution factor. So you can calculate V0, that is 1 by R1 plus 1 by R2, that is the first element, and the next element is minus 1 by R1. Then in the second row, again minus 1 by R1, then last element is 1 by R1 plus 1 by R2. So you can get the value of V0. Then you can find the inverse of V0, that is I have taken that as X0. Then you can find the del value is X0 into P0, where P0 is the transpose of P and P is nothing but the PG. What is PG? That is the generated power divided by base value minus, that is it is a matrix. So next element is demand power divided by base value. Likewise you can find the P and you can find the del. From that del value it is there, or del, two values will come. So third bus, it is reference bus, so I have taken del of 3 is 0. Then I have calculated the power Pij. So I have used a for loop for I equal to 1 to 3 and j equal to 1 to 3. But if I not equal to j, P of I comma j is del of I minus del of j divided by L, that impedance, overall impedance. Then I have found the power. From power I can calculate the generation shift factor, how much the generation, each generation need to shift to reduce the fault, like that. So Aij you calculate as X0 of I minus X0 of j divided by the impedance. Then from that line outage factors, that also you need to calculate the formula. So you need to calculate everything. Then after that you can find the new power flow. So new power flow is old power flow plus the generation shift factor into del P, the difference in power. Okay, like that you can calculate the generation shift factor. So this generation shift factor and line outage factors are used to find the outage, that is a contingency analysis in a power system. So contingency analysis. So every power system network there is a configuration, and so based on the telemeter, breaker and switch status, we can find the network topology. So a fast method for performing contingency analysis is this method, generation shift method. So here the program is written in MATLAB. Hope this is understood to you. So when you before that I am running this program. So I am running this. So I am in the screen. I am getting the reactance between 1 and 2. That is 0.6 and the value 0.4, then 0.8. The generated power is 40 megawatt and the power demand is 130 megawatt and the base power is 100 megawatt. So these are the values I am getting, del value and the generation shift factor A value, and at last I am getting the line outage distribution factors.